Hi everyone. Glad to be with you all today. Can everyone hear me? Is the sound coming through the silent disco? All right, nice. This is new for me. I've never given a talk in this silent disco format before. So my name's George Fraser. I am the CEO of a company called Fivetran. Fivetran is an automated data integration tool that gets data from all the places it lives into a cloud data warehouse. But Fivetran is only part of what I'm going to be talking about today. I'm going to be talking about your data architecture and what your data architecture should look like in an era of cloud data warehouses and how radically different I think it should be in this great new world of cloud data warehousing. There we go. Yeah. So, this is the problem we're talking about, the problem of centralizing all of your data. So if you look like most companies do today, the data about what's going on in your business lives in about 1 million different places. You may have payment processors like Stripe. You have data about what your engineers are doing. You have production database. Maybe you're running Oracle. You have some of your most important data in your CRM system, probably Salesforce. You have marketing tools. You have a new marketing tool every morning and maybe another one in the afternoon, about 1 million marketing tools. And if you want to know what is happening inside of your business, you need to centralize this data. Get all of your data in one place so that you can get a picture of everything that's going on. This is, I'm sure, a very familiar problem to everyone in this room. The most common use case for centralizing your data is BI, but it's not just about BI. You may want to share some of that data with customers and partners. You may want to build products on top of that data. You may want to power operational systems with this central data store. The other problem that we're all too familiar with is that traditional approaches to ETL, which is the way you get data from all these systems into one place, are very labor intensive and very brittle. So traditional ETL tools are toolkits. They give you a bunch of components. Components like make an API call, write a CSV file, execute a load command on my data warehouse. And it's up to you to put these components together into a data pipeline that solves your problem. So you are responsible for the correctness of this pipeline. And anytime there is a change in the data source, that pipeline is going to break and you're going to have to go fix it. And so you end up in this endless cycle of fixing broken data pipelines. You end up in a scenario that looks something like this. So you have this series of people. My favorite thing about this diagram is how they get more sad as you go left to right on the diagram. The process typically starts with an end user who is trying to answer a question. They need a new report that was never contemplated by the ETL pipeline you built. And so they go to an analyst. And the analyst says, okay, in order to answer this question, I need like another attribute from NetSuite that I don't have right now. And so I go to IT or to a DBA or some kind of data warehouse master, and then they go and they say, okay, I need an engineer to change our Python script or our Informatica installation or you name it in order to get this additional information I need to answer this question. They go, they do that, and then it goes all the way back up to the chain, possibly months later. I'm just curious, in this room, how many people are more like on the user/analyst side of this spectrum? Just by a show of hands, okay. And how many people are more on the like IT, DBA, engineer side of the spectrum? It's interesting, mostly engineers, even at the Tableau conference, mostly, okay. All right, great. Well, you're the real winners in this new architecture because your life becomes so much easier. So what we want this to look like is the vaunted self-service insights. This is where we want to get to, where the end user can ask a question that you didn't anticipate when you built the system, and you don't have to go through this chain of people to update the ETL process in the data warehouse in order to answer that question. So this is where we want to be. This is the world we want to be living in. How do we get there? It turns out that when you move to the cloud data warehouses are not just on-prem data warehouses that are running in AWS. They're fundamentally different and fundamentally better And there are other tools that are available to you in the cloud that is going to help you get to this world. So the first thing you need to understand is that cloud data warehouses are really, really fast and really, really cheap. Cloud data warehouses are so much faster and so much cheaper than traditional OLTP databases and traditional on-prem data warehouses that you can fundamentally rethink how you use them in this stack. And I'll go into detail about that in a minute, but the core thing you need to understand is they're really fast, they're orders of magnitude cheaper, and they're linearly scalable. So you can basically just do put whatever workload you want into them. The second thing you need to understand is that in the cloud, there are these great automated data integration tools like us. And an automated data integration tool is the opposite of every data integration tool you've ever seen. So whereas traditional data integration tools are highly customizable, that's what they sell you. If you go ask their salesperson, they'll tell you all day about how customizable it is. An automated data integration tool is the opposite. There are no choices. All of the details of how the data is going to get from one place to another are going to be automated. The second key principle that you need to follow in building an automated data integration tool is it must be resilient. So when the data source goes down, when your database fails over to a replica, the data pipeline needs to be designed in a way that it can recover automatically. So you don't need a human being to go in and intervene, look at the car crash, figure out where it left everything, and recover the data pipeline. And the third key principle that you need to have a great automated data integration tool is it needs to be deployed in the cloud, so that when Facebook decides to change the performance characteristics of their API at midnight on a Sunday, as they want to do about once every 6 months, it's our problem. Your data integration vendor has a staff of engineers who it's going to be a fire drill, but they're just going to go and fix it right then. So those are the three key ingredients to an automated data pipeline that you can just set up and forget. It will operate itself. So if you assemble these tools in the right way, you're going to get a data stack that looks something like this. And I'm going to talk through each layer of this, and I'm going to explain why I think this is the way that you should build your data stack, from left to right. So the first step in this stack is replication. So this is, you need to take all the data out of all the operational systems where it lives and replicate it to somewhere else. Now you'll note in this diagram that these lines are parallel. So if you look right here, my app, my database, they're all going straight in together, which is a key attribute. And I have this diagram to explain in a little more detail what I mean by that. So the traditional way that you do ETL is you don't replicate the data, you actually integrate it in flight. So you take data out of NetSuite, out of Salesforce, out of Google Ads and Bing Ads, and you transform it into some kind of usually dimensional schema before you load it into the data warehouse. This is the classic way of doing ETL and building a classic data warehouse. But what I am advocating for here is that you replicate the data. So you make no effort to integrate the data across sources, and you don't anticipate what you're going to do with the data. Instead, you just load the data from every source in a schema that makes sense for that data source. We're going to deal with integrating the data later. In a cloud data warehouse, this is a reasonable idea. This may sound shocking if you've been using like Oracle as your data warehouse for the last 20 years because it would be so expensive, but in cloud data warehouses, the cost of storage is so low that it is effectively free. So the fact that you're going to be storing all of your data twice here is not a problem, and it's going to make your life a lot easier because you're going to have a clean copy of the original untransformed data sitting there in your data warehouse forever. So when you're troubleshooting your transformations, when you're trying to fix a mistake that you made, it's going to be so much easier because you still have all of the original data, as opposed to a traditional ETL process, which is inherently destructive. You know, once you transform the data, the original data is gone. And if you want to change something, you've got to go back to the source and replay everything. And guess what? It might not even be there anymore. A lot of these systems expire data after 7 days or 30 days. The second step in building this modern data stack is centralization. So you're going to replicate the data out of all the places that it lives. And what I'm advocating for is that you should centralize all of your data into one data warehouse. On-prem data warehouses, it's very common to have multiple data warehouses for different business units. That's the most common scenario, sometimes because of acquisitions, sometimes for different use cases. In the cloud, you should not do that. Cloud data warehouses are horizontally scalable. So you can put all of your data into a single physical data warehouse, and then you can create separation logically. So I'm not saying every single business unit in your company is going to have access to everyone else's data. You don't have to do that. What you do is you use permissions and namespaces to create separation between groups instead of creating physically distinct data warehouses. And the key reason why this is so much better is it's much easier to change your mind later. So later, if you need to change where those borders are a little bit, it's very easy because they're all just logical barriers. All right, so an alternative to this idea of let's just pick one data warehouse and put everything into it that you hear a lot about these days is data lakes. I love this animation. So that's Mugatu from Zoolander. Data lakes. I don't know if you know Zoolander, but data lakes like Hansel are very hot right now. So data lakes have a lot of hype around them. A lot of people are writing blog posts about data lakes. A lot of AWS solutions architects will tell you that data lakes are the thing you need to do. You should put all of your data in one data lake. And this term sometimes means different things to different people. So just for clarity, when I say data lake, what I mean is you're going to store all of your data in an open source file format like Parquet or Orc in blob storage like S3 or Azure Blob Storage or Google Cloud Storage. So data lakes have a place, but they're not for everyone. And I like to think about good and bad reasons to adopt a data lake. So some good reasons to adopt a data lake is number one, to reduce your vendor lock-in. If you have a copy of all of your historical data in an open source file format in a commodity blob store like S3, then if someday you want to change data warehouses, that's going to make it a lot easier. Another good reason to adopt a data lake is if you want to send your data to both a SQL and a non-SQL destination. And the last good reason I think of to adopt a data lake is if you want to send the exact same data to two data warehouses because you're doing some kind of migration. Like you have the old data warehouse and the new data warehouse, and you need to sync both. You need to sync all your data to both of them exactly the same because some team is still using the old data warehouse. You can't get them to move off. Spoiler alert, it's always the finance team. They're always the ones who hang on to the old data warehouse forever. So for a couple years until you can get the finance team to stop using the old data warehouse, you can use a data lake as basically a way station to send the exact same data to two places. Now, there are some bad reasons to adopt a data lake, and I say bad reasons because these are often stated as why you should adopt a data lake, but these are not reasons to adopt a data lake. So the first one is to separate compute from storage. If you want to separate compute from storage, you should adopt a data warehouse that has that feature, like Snowflake or BigQuery. That is the solution to separating compute from storage. You do not need a data lake in order to do that. The second reason people often cite for setting up a data lake is that you're going to store the raw data in the data lake, and then you're going to store the curated data in the data warehouse. And that is a really good idea if it's 2008. So if you're in a time machine and you get taken back to the past, then you should set up a data lake. But all the good modern data warehouses have great support for semi-structured data. You do not need a data lake because you have semi-structured data. The answer is JSON and variant. That is how you solve that problem. And that's the third point there. Semi-structured data is not a reason to adopt a data lake. Okay, so the last key decision you're going to have to make when you centralize all of this data in one data warehouse is what should be the schema. And I advocate for a normalized schema. Some people find this to be kind of a radical proposal. Like if there's any really huge dimensionalization fans here, like don't throw things at me. I know this seems crazy to some people who've been doing data warehousing for a long time, but the problem with dimensional schemas is that they're not future-proof. So every dimensional schema reflects the particular questions you were thinking about answering at that time. And those questions are going to change. And so you should store the original copy of your data in a normalized schema. No matter whatever happens, a normalized schema is still going to be the same. A normalized schema just reflects the data model of the source, not the questions you're going to ask. Now, I'm going to talk about it in a second. You may transform this into another schema, but the landing stage of your data warehouse should always be a normalized schema. That's how we do it at Fivetran, and I recommend you do that whether you're using Fivetran or not. So the third step of this process is transformation and modeling. So if I've convinced you so far, you've ingested all of your data into one data warehouse, you've got it in a normalized schema, you're going to want to model that data in a more user-friendly way. So normalized schemas, well, they have those nice properties I just talked about. They're not very analyst-friendly, and they're certainly not very business user-friendly. So you're probably going to want to transform the data into some kind of dimensional schema or like some giant wide views that just have like one table with a ton of columns. And the way that I recommend you do that is using SQL. SQL is a great tool for transforming data. It's really great at doing, unions and aggregations and filtering and joins, and those are all the things you need to do transformations. You don't need to buy another tool to do transformation. You already have it. SQL is the best data transformation and modeling tool out there. Now, there is an alternative I want to talk about at this stage, which is ELA. So what I just described is often referred to as ELT. The idea is you extract the data, you load it in a normalized schema, and then you transform it using SQL. There is another approach, which is extract, load, analyze. The idea is you don't do any modeling, you just query the original schema. You can, in fact, do this. It's not illegal. The ghost of Ralph Kimball is not gonna come and kill you. Actually, I think Ralph Kimball is still alive, isn't he? I should have said that. Hopefully he's not here. Okay. Yeah, Ralph Kimball is not going to come and put you in jail for not doing dimensional modeling of your data. The scenarios where it makes sense to basically just query the normalized schema are scenarios where the data model is already relatively simple. So it may surprise you a little bit that I chose this as an example of a simple schema, but let's be real, this is actually a pretty simple schema. This is the core Salesforce schema. The core Salesforce schema is really not bad. There's accounts, contacts, leads, opportunities. There's a bunch of join tables between them. Every analyst knows it because Salesforce is so widely used. For Salesforce data, we see a lot of our customers, they don't model it. They just write their SQL queries directly against the Salesforce schema. It's good enough. You don't have to do this. I'm just saying consider it. If your schema is relatively straightforward, you may not actually need to do any modeling before you query it. Now, the scenario where you want to do extract, load, transform, where you want to write a bunch of SQL jobs that transform the normalized schema into something more user-friendly, is where you have a more complex schema. So this is actually an example from Fivetran's own data warehouse. Each of these boxes doesn't represent a table. Each of these boxes represents a data source, which itself has many tables. So this is our marketing activity. So we take the union of those four things at the top, which gives us every event that ever happened with anyone who's ever interacted with Fivetran. We put that into a giant activities table. That's basically our fact table. And then we have a bunch of attributes around things like engagement, buying intent, stuff like that. It's a very common scenario, where you're trying to build basically a fact table of every interaction you've ever had with anybody in the world. And there, you're definitely going to want to transform the data, partly to make it more user-friendly, partly for performance. Doing all the joins you have to do inside of each of those boxes is not a good idea to do every time you load a dashboard. And we have a tool to help you with that. So I said you don't need a new tool to do transformation. SQL is a great data transformation tool. You do need to run that SQL somehow. Some data warehouses have this capability built in, and you can use that. You can also use Fivetran to do it, so we can trigger SQL jobs to run after we deliver the data. So you write the SQL that curates your data into a more performant, user-friendly schema, and we will run that whenever we update any of the tables that are inputs to that transformation. All right, so the last step of your modern data stack is getting insights. So you're probably going to use a BI tool, maybe Tableau. that you're going to plop down onto this single data warehouse. That's going to be a lot easier and a lot faster because you have one data warehouse. You're not pulling data from different places and trying to do federated joins or anything like that. The rest of this process is much easier by virtue of the fact that we've been so opinionated and we've centralized all the data in a single store. One of the cool things, if you use Fivetran, about our tool is because it is so automated and so not configurable, if you have a standardized data source like, say, NetSuite, the schema that we deliver will always be exactly the same. And so we have actually pre-baked some of the dashboards that you might want to use. So because every Fivetran NetSuite user has the exact same schema, we can just build a pre-baked Tableau workbook for you. It may not be exactly what you want out of your NetSuite, but it should get you like 80% of the way there. So that's one of the nice side effects of using an automated data integration tool like us, is that we can actually help you with the downstream components of this system because the upstream components are so predictable. So the last big thing I will advocate for is getting away from this kind of fragmentation. So I talked earlier about how it's common on-prem to set up different data warehouses for different business units. It's also common on-prem and in the cloud to set up different data stores for different use cases. So what people will do is they will set up a traditional data warehouse for their BI workload, but then they will set up some kind of like custom code feeding their production systems. They'll set up some separate system supporting AI and machine learning workloads. They'll usually use CSV extracts to implement data sharing. And instead, what I advocate for is that you use the same data warehouse for all of your use cases. So you have one pipeline that goes into one schema. You set up different namespaces within it, but you run all of your workloads against the same data store. You don't need a separate data store for Python than you do for SQL. And this allows you to avoid repeating a lot of work. So I'll just talk through a couple quick examples of customers who went on this journey, customers of ours. One of them is Oldcastle, who was doing a on-prem to the cloud migration. And they were connecting data sources like NetSuite, Salesforce, SQL Server databases. They were going into Snowflake, and then they were running, their goal was to run Tableau on top of Snowflake. And they brought in us after a months-long internal project, which was not producing results. And in about 10 days, they were able to get the whole system stood up from data source all the way to Snowflake to Tableau. And they were immediately able to start answering questions, which is one of the really cool benefits of the simple architecture. It's inherently more iterative. You can get value right away, answer your most important questions on day one, and then start adding more transformations and models after that. Another example is a company called Cross Media, which is an agency. They were integrating data from their customers. They were using Tableau to build reports on that data, which they then would share with their customers. This was a crucial aspect of their product. So this was a lot of ad data from a lot of different people. Again, they went into Snowflake. Tableau is the BI tool. And they were able to wrangle all these data sources of all of these different customers because the data integration process was so automated. So that's all I have for you. I'd love to take questions if people have them.